Could the moon be the best place for a telescope? Could a rogue star or planet destroy the solar system? And how would humans evolve on other worlds? All this and more in this week's Overtime Question Show. Hey everyone. I know I'm on hiatus right now, and you thought, oh, that's it for the question shows. Well, actually, we're going to be running a whole bunch of question shows all through the summer. And these are coming from the overtime segment. So every time we do a question show on the channel, we actually do them for about 2 hours long. And then we only edit down 1 hour of it for the question show. And the rest is only seen by the patrons and I guess anyone who saw the live show. And we thought, let's just share more of the content. So I'm going to share an edited version of the question show from September. So when we came off of hiatus last year. And so this is a bunch of questions that most of you have never seen, answers you've never seen. And we're going to keep doing this one per week all the way through our summer hiatus. So enjoy this week's Overtime Question Show. Sid Vicious, any updates on the new star you discovered? Triton? Is it technically a trans-Neptunian star? So when we did that 1 year of James Webb observations images, at one point I apparently said something like, and that bright star is Triton. And I had like maybe 10 people say, hey dummy, Triton is a moon of Neptune, not a star. And I'm like, oh. Like, hello, welcome new people who aren't that familiar with my content. Like I went through in incredible detail every single discovery, all of the scientific analysis was done with James Webb. And then like, I don't know that Triton is a moon, not a star. Anyway, so I don't know if I'll and just like every week or so, somebody finds that video and mentions that. And, yeah, like I'd have to say it. I have to say, like what I meant was that bright thing, that bright star-like object that you can't resolve any features on it in this image that really looks like a star. It's not a star at all. It's a moon of Neptune. But clearly that did not come through. That did not translate. Michael Hensby, besides the Moon, Ceres, and other near-Earth asteroids, what low-gravity bodies would you consider best for early industrial activities in the upcoming century? I mean, it's all situational. Like the only application of asteroid mining that makes sense is because you're going to need the chemicals nearby. It does not make sense to mine an asteroid for gold to bring it back to Earth. It makes sense to mine an asteroid for a little bit of water so that you can refuel your lander so that it can get back off the surface of the moon that you're exploring and return to the vehicle and deliver cargo, and then the spacecraft can fly to the next target. So, in the upcoming century, I don't think we'll go past in situ resource utilization. Like astronauts will be harvesting regolith from the moon to be able to build their station. They'll be harvesting raw materials to refuel their engines. That's it. It will never make economic sense to harvest any resources in the solar system to bring them back to Earth. I feel pretty confident that there will never be an economic activity off planet that has anything to do with Earth. That will all be about them using the resources locally. Chris Moore, so the plans for the LCRT on the moon would help scientists look farther than JWST. Apparently, how does that work? Just trying to understand the comparison if possible. So, I mean, JWST can let you see about, say, 250, 300 million years after the Big Bang, which to the first galaxies. But if you had a more powerful telescope, then you could see earlier. You could see objects, maybe see the first stars. There's a certain limit where you've got, too much gas and dust surrounding the first stars. And so you just can't see them. And then the hard limit is the cosmic microwave background radiation, which is 370,000 years after the Big Bang. And that's like the farthest that any telescope could possibly see. Like, yes, you could detect stuff that's like a little farther, but I think the thing that's most exciting is that you could detect stuff that's far, but with much better resolution. And so you could see a galaxy that is 200 million years after the Big Bang with incredible resolution. That would be very useful too. Franco Iacano, as inhabitants of Earth, we have already evolved from our original species. Once out of Earth, how will we evolve besides being able to hold coffee with one hand or a cell phone with the other? I mean, it all depends on the environment that we go into, right? Like if we go and we live in a low gravity environment, then we will probably grow a little bit taller. If we have to experience a lot of radiation, we might evolve more tolerance of radiation. And I think right now we societally experience new technology and we're able to incorporate it. Like kids these days, are more accustomed to using screens when they're children than people my age. But imagine if like evolution takes over on that and we actually evolve with our tools to process computer information differently or better, or social dynamics or things like that. So it really just depends on where we go and what we do. But I mean, we have taken over a lot of our evolution ourselves. Like if you don't have this experience where, if you don't have the right situation, you don't find a mate and you can't eat and you die, right? Like we have enough in our society that people who wouldn't be able to find a mate when we were living in the savannah now can. And so, if you can't see, you get glasses, as opposed to just get eaten by a lion. And so a lot of the stuff, the forces of evolution are different these days. Idea Flame, would a planet orbiting a binary pair of red dwarfs stay habitable for trillions of years with a combined mass of the stars might be similar to the sun if given smaller stars live longer? Yeah. Like the very first couple of billion years after a red dwarf star forms, like it has very tempestuous flares and it would be very dangerous to be a planet that was nearby. But if you're in a binary system and there were like lots of really interesting three-body interactions, you could imagine that you were sort of farther away from the stars, and then you migrated closer over time, and then you settle down and you could be in the habitable zone around those stars for 100 trillion years maybe, which is a lot of time. And yet you would still have liquid water on the surface, and you still have like all the stuff we would have, you would have a lot more time. Aaron Calhoun, can a high velocity star pass through the solar system? Sure. Yeah, it would make a mess. It would tear the solar system apart, depending on how close it came to the middle of the solar system. And so the fact that all of the planets in the solar system still orbit the sun nicely 4.5 billion years later tells us that this hasn't happened. And so it's not likely to happen. We know there's a star called Gliese 7 something. It's going to pass within about 70,000 astronomical units in the next million years. And 70,000 astronomical units is pretty close. It's like less than a light year. So we're going to have a star come. And so that's happened many times closer. Like you can imagine stars will come within 1/10 of a light year, but it's still really far away compared to, say, even Pluto. KGS, can astronomy only be sustainable by tax funding? Yeah, I think so. I can't imagine a private model that would fund basic research in anything. Like, yeah, okay, drug companies are doing basic research for drugs. IBM and Google are doing basic research to figure out technologies they can profit from later on. But for looking into high energy physics and things like that, it has to be done by the government. Like the budgets are enormous and nobody is planning any kind of private endeavor that would stand, like maybe fusion research you could imagine, but no, not astronomy. But later on, when it's valuable, when people have some financial reason to build a really big telescope for some reason, then it probably would take over.
So what you're watching is one of our overtime segments for the question show. And if you want to be able to get a link to all of them, all you have to do is subscribe to us on Patreon for free. You don't have to pay anything. Just go to Patreon. Follow our patron feed for free. We'll show you how to do it right here. And then every week when we publish a new question show during the normal season, we also put a link to the full unedited live stream so that you can watch the whole episode. And then we also put all of the audio from the question shows out to the patron only question show feed. So you can get that showing up automatically on your podcatching software. And for those of you who want more question shows, we're still doing the patron only question show all through the summer. And actually, I'm just a couple of days away from requesting all the latest patron questions. And we're going to share a bunch of those to everybody as well. So we've got tons of stuff coming this summer. So don't worry.
Victor OE, hey Fraser, I'm getting into binoculars. Could you recommend a few and talk about the ones you have? So I have a Celestron 15x75 Skymaster binoculars, and they're great. I love them. So like, that's the one I recommend. They're like, you can get them on sale for like $75, $100 at the most. Or maybe that's a couple of years ago. I don't know. They're amazing. Like they're heavy, but you just fall into the sky
And they're just great for just lying back on a lawn chair, being well supported and looking up in the sky with the binoculars. The pair of binoculars that I really want is Canon has image stabilized binoculars, and they have smaller ones. One's like 8 by 30s, and they have some bigger ones as well. I think they have like a 15 by 45. 15 is the magnification, and 45 is the size of the lenses. And so you look up at the sky, and your hands are jiggling, and then you press this button on it, and then it has this internal optic system that counteracts against the movement of your arms, and suddenly the whole sky just stabilizes. And it's a way better view than using any kind of binoculars, because the sky is now just motionless, and anything you want to look at is just right there. And it uses batteries, but then you unpress the button, and then they're back to regular binoculars, and you find anything you want to look at and you press the button. But they're like $1,500. They're amazing though. Like, it's transformational if you get a chance to play with those. And then the coolest thing, we got an article they're working on Universe Today about this, is someone has built, with a lot of 3D printed parts, a binocular telescope. So it's literally 2 telescopes bolted together with 3D printed parts that you can then look through the eyepiece with both eyes. And there's looking with both eyes is much better than looking with one eye. And you can try this for yourself. Look at some piece of text that you can't see with one eye and you can't see with the other eye, but you can make it out with both eyes. Our vision is better with both eyes. So if we could send iron to the sun, how much iron would be needed to make the sun go supernova? So iron isn't poison. It would be like asking if I was going to give you grass to eat, from your lawn. How much grass would you eat until you died? As long as you were getting food, then it would just pass through as fiber and you would still be fine. And you would just be bored of all of the grass that you have to eat, that your body can't digest, and it had to move through. And so iron is not poison to the star. Iron doesn't cause the star to die. It's that the star doesn't have fuel in its core that it can burn. And so when the star reaches iron, it has used up every other kind of fuel at the center of the star, and it's left with iron. And the iron doesn't fuse. And so there's no more heat and light and radiation coming out from the center of the star. And so that was the only thing that was pushing against it and stopping it from imploding until the star just collapses in on itself. Jeremy Galloway, Fraser, what happened to the claim of the universe being 26 billion years old instead of 13-ish billion years old? Nobody else has signed on to that theory being correct. You can see this a lot. Hopefully you recognize this when you think about all of the things that we've reported about, that one person, compare, say, fast radio bursts, which were first discovered 2007, and someone saw this weird flash of radio waves, and then somebody else saw a weird flash of radio waves, and then somebody else saw a weird flash of radio waves, and then they started to build telescopes that could see more and more of them and started to map them, and they started to measure them and found repeating ones. And you had, if you search for fast radio bursts in the papers, you will have hundreds of them. You've got one paper from one person who's making this one idea that the universe is 26 billion years to solve one problem in cosmology currently. And so, unless other people find evidence that is similar for that thing, it's not going to go anywhere. And you see this time and time again. And so always, my position is that's a cool idea. Nicely done. That's thinking out of the box. And we'll put that over and we'll wait for anybody else to find anything that verifies any of what you saw. And until then, you just have to just move on and go, at one point, somebody had a clever idea that didn't pan out yet. And so we haven't heard anything else in that front. And you're going to see this a lot. And I think if you watch the conversation that I had with Ethan Siegel a couple of weeks ago, he goes into that really well about sort of what it takes for a lot of scientists, for consensus in science. And it takes a long time. It takes a lot of effort. Axel James, does a planet need a magnetic field to be habitable? Venus doesn't have one and has a much thicker atmosphere, so no magnetic field. Would we no atmosphere, or do you need one for the UV light? So we don't know if a planet needs a magnetosphere to be habitable, but we know that if the surface of Earth wasn't protected by the magnetosphere that we have, then Earth would be a lot less habitable. We wouldn't have any protection from the solar wind that was trying to blow our atmosphere away. So we wouldn't have the kinds of chemicals in our atmosphere, and we definitely wouldn't have the water on the surface of the Earth without the magnetosphere. And then what interaction does the magnetosphere have with the plate tectonics on planet Earth? One of the wonderful things is we have this example of another planet just like Earth right over there, and yet it is so different from us. You know, it's the same mass, same size, roughly the same distance from the sun, and yet thick carbon dioxide atmosphere, almost no water located anywhere in the atmosphere, no hydrogen available, no carbon cycle, no plate tectonics, no active volcanoes. It's such a weird thing, and it's a real treasure because we can look at Venus as an exoplanet and study it from that perspective. Brandon Warren, is there any chance of all a planet Vulcan between the Sun and Mercury? Could it be too small to be seen? No, there's no chance at all. I mean, we have really good telescopes. We can observe everything in the solar system. And if there was a planet in between Mercury and the Sun, we would have spotted it. Originally, the theory for a planet Vulcan was because people thought that there was these weird gravitational interactions. Like Mercury wasn't moving around the sun the way it was supposed to. And so people proposed that maybe there's another planet in there that's interacting gravitationally. But then Einstein figured out general relativity, and the predictions that he made about the movement of Mercury around the sun suddenly made complete sense. And so you didn't need to have another planet orbiting in that area. Negroni, how far do you think you could dive into a gas or ice giant with this specially designed craft? Not far. You could, like, it depends on how specially designed you've got, but like the pressures get way beyond what you would experience at the bottom of the Earth's oceans, way beyond what you within a few hundred kilometers. And then you're looking at, pressures as if you were moving through diamond. Like at a certain point, nothing can survive. Kai Pickle, what's your opinion on name exoworlds and exoplanets getting proper names? So I don't know about name exoworlds. I don't know if that's some program people are trying to name a bunch of exoplanets. I mean, right now, I think the only proper way is for the International Astronomical Union to come together and have a way that they name exoplanets. I think they should have like cool names, right? Like these worlds should have cool names. People should come together and they should propose a really cool way to name all the exoplanets, and then they should follow that process, and all these planets should get named. And the only reason that they're not giving them names is because they're scared. Because they don't want the backlash, and they don't want the hassle, and they don't want the administration, but they don't want to let anybody else do it. So be brave. These planets deserve cool names. Dustman, are we starting to realize with JWST that we didn't know much? We knew plenty, but every new instrument that is an order of magnitude better than the previous instrument is both an answering machine and a question machine. And so, yeah, we got answers to a lot of the big questions that we already had in space and astronomy and cosmology. And we're only a year into this, right? But at the same time, it's like just unrolling an enormous amount of weird new observations that now astronomers have all new challenges and questions to go into. It's exciting. I love it. That's always expected. Like when Vera Rubin comes online and you are seeing, I've talked about this many times. Like we know of 1,500 type 1a supernova. And when Vera Rubin comes online, it's going to find like more than 1 million, right? Like we are going to learn new things about what the universe does when we weren't looking. And that's just the benefit you get of this incredible new telescope. Manuel Pingas, how do you feel about not witnessing the humanity story till the end? I mean, it sucks. I would love to stick around and live forever and see how this whole story ends. But, everybody who is born on planet Earth gets to experience however many decades we get to live and see the piece that we do. And I think the time that I get to live, I was born in 1971. Here we're in 2023. I still feel healthy, 52 years old, and I get to see really cool things and smartphones and artificial intelligence and virtual reality and Steam Deck and spaceflight. And yet I will die. And the next generation, future generations, my kids will see things that I couldn't even have dreamed about. And that's just, I don't know, you feel sad, but you feel glad. But, people always ask me, like, if you go back in time or forward in time, be like, forward. And my wife too, right? Like my wife is more future centered than I am.
I'm going to give a shout out to a couple of other websites in a second, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Bill, David Gilton, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Modzo, Paul Rohrbach, Stephen Krasaki, Stephen Filer-Munley, and Vlad Shiplin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Now, normally I tell you some books that I'm reading, some content that I've been watching, or a small YouTuber that I want to shout out. But in fact, I want to shout out my biggest competitor, and that's space.com. They recently celebrated their 25th anniversary of producing space news. And they're the biggest space news website on the entire internet. And congratulations on 25 years of excellent coverage from space.com. And here's to 25 more. I appreciate the competition. All right. I hope you're enjoying the summer hiatus as much as I am. Now I'm going to eat those huckleberries right there. All right. We'll see you next week.